Factoring by grouping is pretty unique because it really is like a halfway point between a few different factoring methods. So first of all, when you're factoring by grouping, essentially what you're doing is you are finding the GCF 3 times. And that's one part of the beauty of it, is that grouping is actually just finding the GCF, which is a method we've already learned. It's just using it multiple times. It's also unique because later when you learn about factoring trinomials where the leading coefficient is not equal to 1, we will actually change those problems to grouping problems and then continue to factor. So grouping does come up multiple times. This problem is actually an introduction problem because it actually shows the problem already factored out somewhat. I drew the line down the middle because factoring by grouping literally means we're splitting the problem into 2 groups, the left group and the right group. And what I see on the left group is that it matches a factor from the right group. That factor is x plus 2. So this is us taking the GCF technically the 3rd time. The first 2 times were not shown in this problem. So when I factor out an x plus 2, which again is the same thing as dividing it, the only thing that's left is the 3 minus x. So this technically would be your final answer here. That got messed up. Let me fix that. The only thing that would be left is 3 minus x, and this would be your entire answer. So let's look at a couple more problems where you can really see how we're taking out the GCF 3 whole times. So one of the hints to know that this is a grouping problem is that it already has 4 terms to start with. So when it has 4 terms to start with, usually it's a grouping problem. So we want to go ahead and split our problem into 2 groups, the left side and the right side. On the left side, I can see that we have a y in common. So I'm left with x plus 3. And on the right side, I can see we have a negative 6. And I'm left with x plus 3. So just to kind of review, that was already 2 times that I found the GCF. I found it on the left side once, found it on the right side. I know I'm on the right track because the part that's in parentheses matches, which is the 3rd time. So for the 3rd time, I'm going to compare them. They both have x plus 3, so that is the common factor. And the y minus 6, the part that's left, is the rest. So that would be this problem completely factored out. Same thing here. I can see there are 1, 2, 3, 4 terms. I'm going to go ahead and split my problem into 2 groups. On the left side, the GCF is 10, so I'm left with k minus m. On the right side, the GCF is negative m, which also leaves me with k minus m. So there's 2 times. Now I'm going to compare the sides for my 3rd and final time, and the part that's left is the rest of my factored answer. So it really is finding the GCF 3 times, once on the left, once on the right, and then once comparing. Let's do a few more. Again, we have 4 terms. I'm going to go ahead and split them down the middle. On the left side, they have an x in common. And I didn't show it before, but again, GCF is dividing. When I take out the common x, I get x minus a. Here, it almost looks good except for the sign. So I'm going to go ahead and factor out the negative 1 because I really want my parentheses x minus a to match. The only way I'm going to factor them out is if they're exactly the same. So we're always looking for that. And then I got my x minus 1, which is my final answer here. I believe I have one more. Yes, I do. So this problem, just to kind of get you in the right headspace, again, I've mentioned it a couple times. You have to look for the GCF first. And in this problem, there is actually a GCF in the whole entire thing. So it leaves me with bx plus bz plus 5x plus 5z. So notice I still have 4 terms inside the parentheses, and this is just my initial GCF that the whole entire problem had in common. So I'm not even going to do anything with that 5. But I am going to split the remaining problem in half. I have a b here, so I'm left with x plus z, and I have a 5 here, and I'm left with x plus z. When I compare the two sides, they both have x plus z. What's left? B plus 5. And then I'm going to bring that 5 down that we took out in the beginning because it is part of the final answer.